Okay, let's start with conventional power plant. So last time we discussed the different types of power plant. So first we'll deal with diesel power plant. So we also discussed last time the combustion fuels and internal combustion engine. So this is somewhat related to that. So what is a diesel engine? So a diesel engine is a prime mover. So for electric prime mover for electric power generation. So, so it has a different capacity up to 5,000 horsepower. That's how big a diesel engine. So mainly in a power plant, this produces a large amount of power. Okay. They are mainly widely used in hotels, utility companies, municipalities, and private industries. This is the nomenclature for a diesel engine. So here, inside this engine, uh, we have discussed previously the pressure and temperature relationship, pressure and volume, as well as temperature and entropy relationship. So here, air is compressed to go inside the diesel engine. So that this air will now get inside the cylinder. No? So what comes out after the four-stroke cycle is the exhaust gases. No? So you have the fuel coming in by means of compression also, isentropic compression. If you remember last time, the four processes and the isentropic compression with just a compression ratio. And we have also water will come in as a means of cooling the engine. Huh? You have water in and out. So this becomes a heat exchanger. So while producing this energy here, it will revolve the shaft inside. So it also creates voltage to the generator. No? So, oh yes. So these are the parts of. Excuse me. Please mute yourself. So we have the following parts: stationary, diesel engine, fuel system, lubricating system, cooling system, intake and exhaust system, starting system, and governing system. No? So for diesel engine, it is a constant pressure. Excuse me. Can you please mute yourself? So we go now to the performance of diesel power plant. Now, if you intend to solve for the Q, the heat supplied by fuel, so you know already what is the relationship, no? That is the between mass of fuel or mass flow rate and heating value of fuel. So we learned last time that there are a lot of questions regarding heat, no? Question in the board exam. So in order to find those, we need to given data, which is the heating value, no? And the rate of fuel. Sometimes efficiency is given, which will lead you to the unknown of either mass flow rate or the heating value of fuel, or the other way around. So we have the air fuel ratio. We discussed also last time the theoretical and actual, no? Air fuel ratio. In the actual, you have the percent excess of air. So we go to piston displacement. What is piston displacement? Is the volume displaced by the piston as it moves from top dead center to bottom dead center. Huh? So this is the formula, volume BD. Piston displacement is the area which constitute pi d squared over 4 times the length of stroke times n, which is the engine speed or revolution, times nc, which is the number of cylinder and number of piston action. Sometimes you will be asked what is the piston displacement. So please do not forget this formula. No? So always remember that all the values given, no, in your problem, you might make a trial calculation. No? If one of the choices will come out, so definitely that would be the answer. But if it fails, no, try again to eliminate, which is not among those added, will be eliminated. So try your best to come out with the answer. No? So this is a four-stroke engine. Divide the engine speed in by 2. No? Okay. So we have the piston speed is 2 times 2L, the distance traveled by piston in one revolution, and angular speed in RPM. We have also the indicated power is the indicated mean effective pressure PMI multiplied to the BD, piston displacement. It is the power developed by the action of piston within a cylinder. So this is measured by the use of an indicator. So that's why it's named after, no? Indicated power. So calculating the indicated main effective pressure is the area times spring scale, no? Divided by the length of indicator car diagram. If working cylinder and crankcase are to be considered, so this is the formula PMI equals E times S divided by L minus E times S divided by LCC. Crankcase or WC stands for working cylinder. So we go now to the brake power. Brake power is the power delivered to the shaft. No? So that brake power is the torque, no? 2 torque times N divided by 60. T is the brake torque. Brake power is calculated using either Prony brake or dynamometer. No? Prony brake. So T stands for the brake torque, N engine rotative speed in RPM, if brake force or brake load, R equals brake arm or torque arm. So brake power in terms of brake main effective pressure and piston displacement. So we have to multiply only the uh, mean effective pressure times the piston displacement. So you can get already the brake power. Huh? So we go now to the friction power. Is the power dissipated in an engine through friction. So the friction power is also the difference between indicated power and the brake power. Huh? So calculating friction power using Morse test method applied to a multi-cylinder engine. Consider a six-cylinder engine. So in the six-cylinder engine, the indicated power fires up, no, firing the six cylinders. So that indicated power at six cylinders is equal to brake power 6 minus uh, FP 6 friction power. Okay, and so on and so forth. No? So we go now to mechanical efficiency. Is the ratio of the brake power to the indicated power. So that is output over input. So the brake power is the output while the indicated power is the output input. So in other form, mechanical efficiency aside from PB over PN I in D is equals to PMB over PMI. PMB stands for indicated mean brake pressure, while PMI stands for the indicated mean effective pressure. So that's mechanical. We go now to generator or electrical efficiency. The ratio of the generator power to the brake power. So the output over input. So the output for generator is the generator power. Huh? So the diesel will drive the engine will drive the generator itself, so the motor. So that the output of the brake power, so because the input is brake power, no? Supplied to the engine or coming from the engine, it produces generator power. So that's the output. No? We go to thermal efficiency. So again, we discussed last time in the combustion fuels or the international internal combustion engine. We have the indicated thermal efficiency is equal to the output over input. Again, the input is the fuel with the heating value and the output is the indicated power. So we have the brake thermal efficiency. Again, that is related to input fuel divided by or the indicated power, brake thermal efficiency. The same with the indicated thermal efficiency. It's the ratio of the brake power to the heat supplied. So this is wrong, no? This is not indicated, but brake power, no? PB. So we have also the combined overall thermal efficiency. So we know last time that we can combine diesel and gasoline engine, no? So for combination or overall thermal efficiency is the ratio of the electrical or generator power to the heat supplied by the fuel. So that's generator over fuel. So we have also the engine efficiency, which is thermal indicated and over efficiency. Indicated efficiency. Engine efficiency is the ratio of the indicated thermal efficiency to the ideal thermal efficiency. You have also the brake engine efficiency is the ratio between the brake thermal efficiency to the ideal. So if we talk about efficiency, it's always output over input. So determining what kind of problem, so you will know the input first, and then try to find out also what is the output. No? So you don't have any problem anymore in distinguishing whether uh, what what is required for an efficiency. No? Normally, there will be a lot of efficiency. If it's not the unknown, then it would be given in the problem. Then knowing the context or the meaning of efficiency will give you easily no? the solution of such problem. We go to volumetric efficiency. So again, that is output over input. No? So always remember that in a ratio of volume of air drawn into a cylinder to the piston displacement. No? So uh, you can try this one. This is B1 and B2. No? Or this one here is BE over piston displacement. No? So output here is the volume at A. No? Divided by piston displacement. That's the volumetric efficiency. So where BE, as per our gas law, PB equals MRT, volume of air. So you can compute BE here from this formula. And you have also the formula for piston displacement, which I asked you to memorize. No? Specific fuel consumption. This is the mass flow rate of fuel consumed per unit power developed. Huh? Okay, so we have classified here indicated and brake. Huh? Ratio of volume of air drawn into a cylinder. So we have the indicated, which is specific fuel consumption. If you are asked what is the indicated fuel, no? So that is just the ratio of the mass of fuel divided by indicated power. No? We are talking about indicated here. No? So that's the relationship. So what is the unit given? Kilogram per kilowatt hour. No? We have one question during our last major exam, our prelim exam. So we have this kind of question. Kilogram. The outcome is kilogram per kilowatt hour. So that is the unit weight of fuel uh, divided by the kilowatt, which is the indicated power. So the brake, same thing with brake specific fuel consumption. It is also the rate of fuel, but the denominator is brake power. But for combined, we combine the two. So that is the generator, which is the denominator. We are not talking anymore about the indicated power and the brake power of the diesel. But in the combined, we already talked about the generator. Once its energy is now transferred to the generator, creating that electrical power. So that is the combined now. So in a diesel power plant, we also need to have the heat rate. So there are some questions that might be the determining factor for you to become top-notcher. No? These are hard questions, but not necessarily hard if you know No, if you you are good in this, so this will not be hard for you. But we will also be asked sometimes what is the plant heat rate. No? So if we talk about plant heat rate, that is kilojoules per kilowatt hour. No? So this is kilojoule hour. This is also kilowatt. So what is added here in the mass of fuel is just the heat, no? Heat supplied because there is a heat during the process of isentropic. Now you have the relationship of its processes like process 1, process 2, process 3, process 4. If you can remember process 1, this is polytropic compression. Uh, uh, there are four cycles in the four-stroke engine, right? So the first stroke is the intake of air, no? The second is the power, the compression, no? And the third is the power, no? And the power cycle. And the fourth one is the exhaust, no? So try to remember that. So here we asked about the heat rate, no? So what is heat rate? Is just the fuel rate times the heat, no? Supplied divided by the indicated power. No? If the board problem did not specify indicated or break, so you can use only the whatever power is given. No? Either it is indicative or break power. So it does not mention the what kind of power. You know what is indicated, right? And the break. No? So you can use that one. Or if it's not, if what is given is only the combined, no, heat rate. So you can use generator power, no? But then again, when you talk about heat rate, always remember the unit, no? The resulting unit will be kilojoules per kilowatt hour. No? Always remember that. And if you will not reach that kind of unit conclusion, so meaning to say your answer is definitely wrong. No? You have to consider that the outcome when you do the computation will always comes out in kilojoules per kilowatt hour. Nevertheless, if you are having problem, you can skip, no, to this kind of problem. Once you reach to the 100 items, you can go back, no, try to put a indicator in your questionnaire. No? You have to go back. No? You can write an X, no? in that in that number 50. You can write X so that you can easily go back to where you need to have to correct, or there is an unsettled item that you need to correct. No? So that's how you deal with your board exam. No? So we have the generator speed. So oftentimes we always remember this. No? It is the 120 times frequency over the number of poles. No? But this, if the poles is not given, so you can assume 4 or 8. No? So you can try to assume, and then whatever will be the answer that should uh, be chosen, no? among your best answer. So we have the energy stream. So here you have the useful work, you have the friction, radiation, cooling loss, exhaust loss, and the heat. That is the energy stream. So we have here items, heat loss, heat input, cooling loss. So these are the formula. So if you ask what is the useful output, break output is kilojoules per hour. 3,600 times break power. Or heat input is rate of fuel times the heat supplied. No? Or percent cooling loss is 3,600 break power over rate of fuel. So we have the common formula for cooling loss: mass of water times specific heat of water times change of temperature or delta T. No? That is for the, what is that? Heat loss. No? And heat input is rate of fuel times heat supplied. Whereas the percent cooling loss is this one. No? So if we talk about the percent cooling loss, it's like the efficiency, no? Wherein the denominator is referring to the fuel, no? So how much is cooling is lost, no? So cooling is formula is MC the delta T over the rate of fuel, no? Times heating value. So that constitute the percent cooling loss, no? So we have also the exhaust loss, which is the mass of the gas times the specific heat of the gas, delta T of the gas. No? So the heat input is the same, no? Mass of fuel times heat supplied. Whereas also the percent cooling loss is the ratio between the exhaust loss or the heat, uh, what is that? The heat loss divided by the fuel or the heat input. Heat loss divided by heat input. So we have also radiation, friction, and accounted losses. So these are the losses that you may find in your diesel engine. Okay, the difference. What you mean by difference? No? So the difference between radiation loss, friction, and accounted losses. Whereas the heat input is still the same, no? So all throughout you have the same formula for heat input. That is the rate of fuel times the heat supplied. Whereas the percentage cooling loss is 100 minus the summation of 1 to 3. What is 1 to 3? Radiation, friction, and other accounted losses. No? So this is the closed system for diesel engine. Okay. So we see here in this part, energy balance, TA minus TB. Then in the center we have this one. So we have the air out and air in. No? So So energy balance QWG equals QW. No? Where's QWG? And calling QWG is water jacket. No? Mass times of water times specific heat of water is equals to mass of water, specific heat of water, and TW. No? So this part here is air, this part here is water. No? And water will also come here. So water heat recovery boiler. So this is water heat recovery boiler. We have the engine. So we have the exhaust plus gas. So this is the waste heat boiler. So the unwanted gas will go inside the waste heat boiler to preheat this water here. No? So there is entering cooling water passing. It goes to the this waste heat boiler. So this boiler is now being heated by the use of exhaust or flow gas. That's why it's called waste heat recovery boiler. So there's an increase of efficiency because this boiler is using a, a form of energy which is not produced by adding a new fuel but reutilizing the source of fuel, no? The unwanted gas, the exhaust gas from this engine here. So in the case of like generator, no? So the exhaust of the generator will be used to provide heat, no? To the waste heat boiler. No? It will produce steam by not necessarily employing other forms of heating value of fuel, but only the exhaust gas. No? So energy balance is Q of steam equals Q of gas. No? Because that is the heat that is entering the boiler that is needed to produce the steam. So this is the formula for mass balance. So there is a lot of question in the board problem talks about heat transfer. No? So you know what heat transfer is all about. No? Heat is equals to zero in the environment. No? So that is the equation between two forms of substances, whether it's a gas or a steam or a water or fuel. You need to be you need to have an energy balance. So we have the boiler efficiency. We started in the beginning about boilers, no? So be able to refresh all your memories with regard to boiler because in the board exam, as you will know, there will be coming out, no, 4 or 5 times, no, related to boiler, no. So that will give you an added score if you know more about boilers, no. Example, efficiency of boiler, that is output over input. Now, what is the output in the boiler? Is the steam. What is the input with regard to waste heat boiler? So that is the heat from the gas, no? Heat from the exhaust gas. So what is steam? Is the rate of steam multiplied to the enthalpy of steam minus the enthalpy of water. No? So there is a correlation between the enthalpy of water. It's always been the difference because the amount of enthalpy will be lessened because of the water temperature. But since the water makeup is always feed with a feed in a preheated condition, no? Just like when we use what was that? What was device? Economizer, no? Economizer utilized the heat of the flue gas, thereby preheating the makeup water, no? So that the difference of enthalpy is so high that when multiplied to the rate of steam, the Q the Q or the heat supplied inside the boiler is also high. No? So this is the formula for the heat of gas, no? Mass of the gas, right? The specific heat of the gas and the change of temperature. No? So with regard to high altitudes, this is the formula. We have the English and SI unit. No? So PE stands for the standard power or power at sea level. No? So we have the PECT, that is the new pressure, actual barometric pressure in mercury. No? T is the new temperature or actual temperature in Rankine. No? Rankine. So plus what is Rankine? Centigrade to Rankine. So what is added is plus 273. No? So the decrease in pressure is approximately 1 inch mercury per 1,000 feet elevation. So when you go higher, no? So there is a decrease in pressure. The decrease in temperature is approximately 3.6 degree Rankine per 1,000. So So that's how you compute, no? What will happen if you go at high altitude? So there will also be an inverse, no? Proportionality. No? The higher the elevation, the lower is also the values of pressure and temperature. So this is now the relationship, no? 1 inch per 1,000. So that is deducted from the standard values of mercury, 29.92. So it will lower the ECT, that is the actual barometric pressure. So when you are inside in the airplane, so I think we have a midterm exam on this. No, what is the altitude pressure when the pilot, no, uh, who is sitting on the chair compartment? So you're asked what is the mass or with regards to the given elevation. No, so that is one of the question. After the boiler, I mean the first topic on diesel power plant, we go now to the steam, no, power plant. So a steam power plant is a good sample of a Rankine cycle. So this is the standard for comparison of steam power plants. No? So always remember the cycle and the process. No? So first you begin at the boiler. No? So from the boiler it produces steam. So we have the steam generator, no? Or steam turbine. So the turbine will run because of the pressure of the steam. So we generate an output, electrical output. So where can we see a steam power plant? What kind of power plant that we have now utilizing steam? No? So aside from the boiler, steam power, we have the thermal, no, power plant is used also steam, no, the thermal. So you have the steam generator, steam turbine. Then after that, you want to pass the steam to a condenser. No? So it's a form of a vaporized steam. So it will condense back into liquid. No? So of course the cooling system provides for water. No? So it goes back to its original state of liquid, no, substance. So it will be pumped again to the boiler, no, in the form of a make-up water. No? So with that, it continually supply the boiler, thereby monitoring and constantly, no, providing the minimum, no, if not the maximum level of water inside the boiler. No? So that completes the cycle. So we have the TS diagram, temperature and entropy. So we have the temperature and entropy. So at boiler uh, part, we have here mass. Well, it's not so clear to me, but we have here the process. No, 1, 2, 3, 4. No, so that's the temperature and entropy diagram. So we have here the constant temperature happening on this stage here. No? So that's of course there's no constant temperature inside the boiler and the steam turbine. No? So it happens on the opposite side. So here is the production of steam. No? It's critical because you have to bring the temperature here. The highest temperature will be here. That is here when you produce boiler steam. No? So it goes down. No? It goes down. from this stage up to here. So that is the polytropic compression right there. No? I mean the uh, this is now the entry, no? Going to the boiler to the turbine. No? So we go now to the processes of Raikkonen cycle. So these are processes: number one, isentropic, then constant pressure, then adiabatic pumping, and constant pressure addition. So prior to the adiabatic pumping, uh, 3 to 4, no? This one, 3 to, this one, no? Then 2 to 1, 4 to 1, constant pressure addition in heat boiler. So this one, the stage here, no? So you have the isentropic expansion here in the turbine. So analysis of the Rankine cycle basing from these processes, we have the heat added in the boiler. It happens in point 4 to 1, no? So this is 4 to 1 here. Okay. So this area here is the heat added, no? So the heat added in the boiler is H1 minus H4. So we have, of course, H1 here and H4, no? So you can have a difference between heat H1 and H4. Okay. But of course, H1 is higher than H4, so you have to have difference between H1 minus H4. So that's the heat added. So here, this is the area of the heat addition, which happens here. Constant pressure addition of heat boiler. So after that, we go to 1.2, 1.22, then 2 to 3 in the condenser. Okay. So this is just the opposite. So we go now to heat rejected. The opposite of the heat added in the boiler is this one, no? So what happens here? The energy balance is between 3 and 2. So it is 3 and 2 here. So that is enthalpy 2 minus enthalpy 3. So we have the heat rejection is mass times H2 minus H3. So the unit is kilowatt. So for the turbine work, if we go to the turbine section, it's the H1 minus H2. Huh? So note if change in kinetic energy is given, so you have to account the difference of kinetic energy. You have to add it. No? That is KE, kinetic energy minus 1 minus KE2. Actual turbine work is thermal efficiency times the theoretical work, huh? Or the turbine work. So we go now to the pump work. We have energy balance. We have exact pump work. No? So pump work with stages 3 to 4. No? So you can see from 3 to 4 there's an increase in temperature there. So we have pump work mass times H4 minus H3. Approximate pump work is that there is a volume F3 times P4 minus P3, or pump work equals mass times BF3 times P4 minus P3. Net cycle work. When we talk about net cycle, there is the difference between the pump work and the turbine work. No? So that is the net efficiency or the heat added minus QR. So this is the same uh, formula when we talk about combustion of fuel, right? And also the internal combustion engine, the diesel engine. No? So the network is QE minus QR. No? Because there is heat reduction all the time. No? We cannot account for the losses. We cannot absorb the losses. The losses are always losses. No? It always comes out to the system. There is always a loss of heat. No? Probably not due to the leakage, but there will be thermal losses all the time, especially in steam power plant, no? That utilizes boiler. No? The boiler efficiency is so low because of the many losses. No? Apparently, the technology was not able to increase. No? Instead, that they come up with a combined cycle. So we're able to increase a little, not so much so that it will not reach up to 80 or 90. Probably they can only hit 60 to 70%, no? Due to the combined cycle. So that is the network efficiency. We go to the thermal efficiency. Always remember that in the boiler, no, or steam power plant, it's always come out the thermal efficiency. You should always memorize this. But with due knowledge about output over input, you can always remember that output is the work, no, the network. What is network? The heat added minus the heat rejected divided by the heat addition, heat added. No? So that is QE minus QR over QE. No? Or by using enthalpy, if if the network and heat addition is not given, so you will just use the enthalpy. No? H1 minus H2 minus work power. No? Or pump work. This is pump work. No? That is the thermal efficiency with regards to this this stage, no, where pump work. No? This is H1 minus H2 minus WP over H1 minus H3 minus WP. That is the thermal efficiency. Again, with regards to the steam rate, no? Aside from the steam rate, we have the heat rate. No? So the steam rate is equivalent to the kilogram per kilowatt hour. No? So the steam rate is not about kilogram per hour. No? Just like the fuel rate, you have the fuel rate in terms of kilogram per hour, but steam rate is not the same. You have kilogram per kilowatt hour. That is 3,600 over the work, net work. No? What is the net work? QE minus QR. The piston displacement. Okay. We go now to the reheat cycle. In the beginning, we started off with Rankine cycle. So we go now to the, if you are asked what is the cycle, standard cycle used for boiler or steam power, so you can answer Rankine cycle. You should know the different cycle related to the different power plants. So we go to the reheat cycle. What is reheat cycle? So reheat means the process where after applying heat, you will apply again another heat. So that's reheat. No? The efficiency of plant sometimes can be increased, no? By withdrawing the steam from the turbine after it has partially expanded and piping the steam back to the steam generator for reheating. No? Okay. This is also has the effect of reducing the moisture content of the steam in the turbine, limiting the amount of moisture to 10% or 12%. So there is also a turbine, no? That can be suitable for steam with moisture. Otherwise, this turbine cannot be exposed to moisture. There should be a 0% moisture. Otherwise, it will create corrosion and pitting to the turbine. No? So this is important because the water can cause increased turbine blade corrosion. No? So in the process of reheat, it also has the function of removing the moisture. No? So where is the reheat? So this one. Okay. You put another stage here. Instead of throwing the all the moisture here at this point at 4 for expansion, no? So it bypass, it goes into the inside of the reheater, no? At this one, two, no? The main purpose is to reheat the boiler water inside, no? This steam generator. So it goes back again to the turbine and it release here, no? So you have added now the corresponding activity or process, no? So that instead of 4 process, you have now 6 process due to reheat cycle. Okay? So what is added here is 5 to 6, the diabatic pumping in the first pump. Okay, ano? That's before, but yeah, process is already extended up to 5 feet. So what is added here is 1 to 2, no? Partial isentropic expansion in the turbine. No? There is partial because it was bypassed. No? There's no full isentropic expansion. No? So that is what is added. Okay, superheating in the reheater. So that is also added. No? So if you will be asked what type of cycle in the boiler processes or steam power plant that increases the efficiency or providing for the reheater, no? Providing for partial isentropic and what is added there? Superheating in the reheater. So if it mentioned about partial or reheating, so that means that is a reheat cycle. Okay, take note of that. So by 4 months of the reheat cycle, so the energy is no longer H1 minus H2, but H1 minus H6, no? From here up to here, six is here, no? So from the first process to from here to the last part, that is the heat, no? So H1 minus H6. And what is also heat added is mass of, what is the mass of that? Is that water or air or fuel? Of course, that is water, no? So mass of water or steam, no? Times H1 minus H6. So M is the flow rate of steam in kilogram per second. So why it is added here? H1 minus H6 and H3 minus H2, because you have now the process of reheater and this one is the boiler, no? So that's why it increased efficiency because you are adding reheater, no? Reheater is a heating device, no? It added to your system to boost the capacity in terms of efficiency, in terms of adding additional, everything is added, no? So we have also the heat rejected. It's now going to happen at each 4 to 5. What is 4 to 5? Constant pressure rejection in the heat heat of the heat in the condenser. So which is where is the 4 to 5 here, no? That is where the heat rejection will take place, no? So the lower the rejection, it means a higher efficiency or network. But the higher the heat rejection will also mean a lower network heat addition. No? So that is the heat rejection. So the turbine work is no longer H1 minus H2 but H3 minus H4. This is what happened to the gasoline and the diesel engine. No? So remember last time the combination of gasoline and diesel, dual combined cycle, it increases the efficiency of the engine, no? Of the four-stroke cycle engine. So same thing with the boiler or steam power plant. No? So the steam turbine will increase energy due to the steam turbine work and the reheater work. No? H3 minus H4 and the H3 minus H4 of due to the turbine. No? Or the boiler itself. No? So where is H3 minus H4? Here, no? This one. 3 to 4. This is due um, to the boiler itself, no? Producing steam. So dalawa ang production dito, no? 1 to 2, which is the reheater, and this one is the boiler side, no? So you have two lines here, no? For the substance that will get inside the work net. The work that is added and the minus the work the heat, the rejected heat. No? Then we go to the pump fork. So process it 6 to 5 is the pump for exact. Approximate is by volume or mass. No? We have the network cycle. We have the thermal efficiency, steam rate. No? After the reheat cycle, we have the regenerative cycle. What is regenerative? No? Cycle efficiency can be increased further, no? By bleeding a fraction of steam from turbine and using the steam for generative heating of the feed water. So, so it looks like the same with reheat, no? But regenerative is also has its own characteristic. The steam may be fed either to an open heater in which the bleed steam comes into direct contact with the feed water to be heated or to a closed heater that is a shell and tube type heat exchanger. No? So this is now the regenerative cycle plant. So these are actually the types of plant that is being used nowadays, no, to increase the efficiency. So aside from the reheat, we have the regenerative cycle. No? So where is the regenerative cycle? Instead of the reheat is inside the boiler, but the regenerative providing for the open heater, no, here between the two pumps. Okay, the output of the turbine, which is the input coming from the input, will go directly to the open heater. No? So the open heater, well, there's a warm water here for taking heat, no, coming from the hot, no, hot water or hot steam, no. So, pwede pa yung magiging hot steam there because it was directly coming out from the turbine. It did not pass through a condenser, no. So it could be considered as steam here. But it will take time to be heated in the open heater. So what will be pumped there is no longer a steam, but it will be form of a liquid. Liquid will be pumped again to the boiler. No? So this is now a water or vapor, no? That is heated with higher temperature. No? So much so that when it enters the boiler, it will only take some time to produce steam, no? Because of this kind of what we call regenerative cycle. So regenerate, no? It will regenerate steam. No? So again, it's it added one process. No, instead of six, so we go now to seven. No? So if you were asked what is the type of cycle relating to steam power plant that has seven processes, no? What are the seven processes? So these are referring to regenerative cycle. So for the six processes, we have the reheat cycle. For the four processes, that is the Rankine cycle. No? So this is the analysis of regenerative cycle. No? So just read all through them. We can discuss until only up to 10:30. So I'll go directly to the next power plant. Okay, this is the reheat. No, after the reheat cycle, we are combining the reheat and regenerative. So what will happen? There is the reheater here and also the regenerative here. So we can combine further in order to increase the efficiency. No, so if you happen to land to a job where there is steam power plant like geothermal, so you will expect this kind of technology. You have the reheater and the regenerative cycle. Okay, so that's all about the processes. See, you have reached already up to process 10. No? Can you imagine that? From 4, you increase now to 10. The main purpose of which is to increase the efficiency, right? So you can see the energy balance. It's already 1 up to 9. Okay, the heat rejection, no? Is no longer the same. No? So you have the energy balance for turbine work. So that will be an additional challenge. Instead of 4 processes, you will take note of the different cycle. Aside from the Rankine, we have the reheat cycle, we have regenerative cycle, we have the combination of the reheat and regenerative cycle. So we go further, we call it regenerative heater. The open heater and the closed heater. Okay, we go now after the non-renewable. So we should have discussed the coal power plant, no? But it was not there. But the coal power plant utilizes also boiler, steam power, no? So that is also a Rankine cycle, no? Coal power plant is, but only the fuel is supplied, which is coal. But what the system is using is the steam power, no, or the Rankine cycle. But then again, you can use reheat and regenerative cycle. But the other plant which is different is the engine. No? So the production of gases, exhaust gas. No? We can have the waste heat recovery also to produce steam in the waste heat boiler. No? So can you imagine why mechanical engineers are employed to do the work of all this power plant? No? You can work with electrical engineer, chemical engineer, and you have a power plant manager who can be a mechanical engineer and at the same time an electrical engineer or a chemical engineer. No? So this is where the main essence, where the theory is very important, no? With regards to finding all the energy, the work, the efficiency, no? Related to the power plant. And what are the different components and processes involved. No? So as a matter of theory and practical application, it is only the mechanical engineer who's the distinct and separate knowledge. No? That's why we are being entrusted to handle this kind of, we can say, very top job. No? Can you imagine that one negligence, no, unable to monitor the plant, no, will make, no, some problems, will make some trouble in the plant already. And who is to be blamed? Can you blame the other? Of course, you cannot blame them. But you, as the mechanical engineer who are tasked in the assignment, no, of course, you will be assigned to different sections, department. But the longer that your tenure and your experience on those area, you will be elevated, you will be promoted, no? No? More power, more responsibility. But more responsibility, more money, no? But that is only ideal. But the main purpose is to really support, no? To give contribution to what your responsibility is called for as a power plant manager, as a power plant supervisor, no? You are more knowledgeable of all the facets, of all the corners of the power plant, no? This is why this is the major thing in mechanical engineering, because this is where the work which is more challenging in nature, no? Which is uh, more aside from challenging, it will give you more uh, values, no, with regards to your profession, no, because it is a higher form of responsibility, no? Working in a power plant. So you know already what is uh, the main reason why power plant evolved and continuously be running, no, whether it's coming from geothermal source, no, if it's a solar plant, if it is coming from a boiler source producing steam, it can be coal, it can be waste heat recovery boiler, whether it can be a regenerative cycle, whether it's from an engine like a diesel engine, a dual cycle engine, and so on and so forth. No? So this is our geothermal power plant. I have only 10 minutes. No? So this is the source of energy coming from the hot, no, hot water in the ground. No? That because of so much pressure, it boils. No? It boils, and then where there's no more uh, way out, no, there's no more possibility of staying on the ground, on the below the ground. So what will happen? It will generate steam. No, the steam will always go up. No, and that is the beauty of nature, principle of nature. The steam will always go up. So that is where the production will be dig upon. No, so in order to find a good source of steam in the ground, there's uh, an investigation. No, uh, it's a kind of survey that you need to conduct in order to find the best location to generate steam. So after that, you put it inside a flush tank. So you know already what is the purpose of flush tank, no? To separate steam from the water, no? So that the water or moisture will be re-injected again to the well. How to re-inject? So you need to dig again another deep well here, no? So it go back on the ground, no? It will be combined to that nearby production well. So the steam is working again. Same scenario with the steam power plant, no? Like we have a steam turbine, no? Still the same. Only that the source is that will no longer produce steam by way of fuel, no? Because the fuel is already there, no? This already a hot water, no? Because the fuel might be the fossil fuels underground, no? So what is the element of fire? To create combustion and fuel or heat ignition. Okay, the presence of three will be there. Fire, fuel, and oxygen, no? So that produces the steam. Same thing with nuclear power plant, no? because of the uranium. No? It's a high form of fuel that can that can form water into steam. So after making the steam, that is the nuclear power plant here is the cells, no? Nuclear cells, providing for the heat in order to turn water into steam. No? You have a water supplied in the nuclear plant. No? So the water will be boiled into such temperature. So you know already the boiling point of water, 100 degree, no? More than on top of that, the steam will be critical steam. It can reach more temperature up to 200 degree, 500 degree. That's where the critical steam is produced. No? There is also a one steam production at a, a certain second or minute. It automatically produce steam. We don't wait for some time to produce steam. No? So that's where the fluidized bed uh, boiler, no? Later on, you will encounter more types of boiler, no? There are a lot of boiler that's used, no? We have boiler for biomass, we have boiler for coal power, we have boiler for steam turbine, no? We have boiler for geothermal power plant, no? So this one is a boiler, but it's put in a flash tank, no? We have the magma, no? You know already what's magma? Because we are located in the ring of fire. No? We have a lot of volcanoes underground. No? So in the Pacific Ring of Fire, we have a lot of magma. It is a molten metal within the earth, which stores energy heat surrounding water, thereby producing steam hot water. So you can see the lava and magma produced when after the explosion of volcanoes. So that's where the hot water or steam water. So we'll bore. So you'll read more on that. That is all about the terminology. It will come out, no, in the board exam. So please be familiar with these terms. So we have the types of geothermal, dry or separated steam or single plus. We have separated steam, hot water plus. So the main function of all those is just to separate water, no, from the steam, because you don't want water to be carry over to the turbine. No? It will be detrimental to the turbine blade. No? So you have the single plus plant with pump wheels. No? So these are the different types of geothermal. We have the binary. So why it is termed as binary? So after the hot water, we'll have another heat exchanger. No? To make sure that uh, heat is being constantly uh, produced, no, at particular level, no, enough to sustain the amount of temperature that goes inside the turbine blade. No? We don't want a temperature, low temperature to get in. It's always a standard temperature. That's why we need a binary geothermal additional heat exchanger here. No? So you'll just try to read and understand the different cycle. So we have the performance. We are running out of time. So we have the sources of thermal energy or the thermal hydrothermal fluid, geopressurized brines, 3 kilometer, no? 3 kilometer from the ground, hot dry rock, magma. So when you see magma, molten rock, that is 1,200 degrees centigrade. Can you imagine that? So we are done with geothermal. We go now to the gas turbine plant. So what is happening in the gas turbine? So I was there in Kuwait for some time. We have natural gases, no, that is also produced, no, due to the fossil fuels underground. It produce natural gas, no. So this kind of plant can run as much as 10 megawatts and further, no. Large unit operate from 10 to 230 megawatt. So we have the air standard cycle. So air is also in a form of gas, but that is not the kind of gas that we are dealing with hydrocarbons, no? So this is just natural air, no? So natural air, just like the aircraft, no? We have the air standard cycle. We need to burn the air at the combustor. So the gas is going to run the turbine. So this is what happened in the where the high octane fuel, no? High octane fuel is used for the aircraft. No, that is the air standard cycle. That is what is used uh, as a standard cycle for gas turbine. We call it Brighton cycle. No? This is the standard Brighton cycle. So we have here one, start here one at low temperature, then go to second temperature because of compression. No, you have to typically compress the air. No, 2 to 3. This is now where start the combustion. No, and 3 to 4 the expansion. Then going back again to the opposite of the combustor. No, oh, that is heat rejection. No, heat is added in the fuel here. Okay, but this is also heat rejection here. There is the exhaust gas here. No? It's like an engine also, no? Compressor and the combustor. No? That's where the Brighton cycle. So that's what happened to the air and gas. It will be compressed and it will be ignited, or the process of combustion will take place inside a combustor. No? So this is the performance of the Brighton cycle. So you just read them. You didn't have to confuse with other performance because they have different performance because they have a different cycle, which is the Brighton cycle. No? Different from a Rankine cycle and a diesel engine cycle and a gasoline engine cycle. So this is the lucky 9 points to remember gas turbine. No? Yeah, remember that one. So finally, we go to hydroelectric power plant. Do we have boiler in the hydroelectric power plant? No. We utilize the wave, no, the tidal wave or wave of the sea or the river or whatever sources of water at high elevation. We have also what we call the pump, no, pump station. No? The pump station will generate power from a low level. No, it will extract water or seawater, no, nearest to the sea. No, so this is the hydroelectric power plant. You have a dam. Dam is the storage of water. No, so you will not allow all the water to go through the turbine. So you have to regularly regulate the water. You have the pin stack. The pin stack is the opening of the gate. No, so to control the amount of water going to your turbine. That is the high head impulse turbine. So the high head. So this one. So the high level is the so-called high head. Okay, this is letter. This is letter B, letter A. So this is the high head impulse turbine. Okay, so you know already that turbine is like a pump. No, it's a impeller itself. But this is not a high temperature turbine. There's no water uh, uh, change at all. No, you can have a high temperature here due to the heat of the sun, but no matter what, it will not change the substance from liquid to gas. But what transfers the energy is just the rotation of the blade, no? Because of the pressure supplied by this the downstream of water coming from the dam. No? So we have the reservoir, headwater, spillway, dam. So you can read all about hydro electric plant. No? So we have the gross head. These are the formula, friction head. So we utilize Darcy's flow of equation because there is friction. No? If there's friction, that's Darcy's equation. We have the length, coefficient of friction, inside diameter, net head, Hg minus Hf, fixed pin stack efficiency, volume flow rate, water flow power, turbine efficiency, generator efficiency. So these are all the same, no? As you can remember, we're always using turbine. There's no way that a power plant can produce power, generator power without turbine. No? Even the biomass produces steam, utilizes steam turbine. And the buying of steam turbine will cost you more or less. No? And even the nuclear power plant uses steam turbine, no? To produce steam energy. No? Always remember that. So there's a need for you to read all about steam turbine, steam generator, because these are the major component that a mechanical engineer can understand. No? There are always an update of technology which you need to understand and which you need to comprehend more. No, this is the impulse turbine. So you need to differentiate what a Pilton from a Francis and Kaplan turbine. I give you already a table for that. No, reaction turbine and impulse turbine. Okay. So in the Pilton, the movement is tangential. No, we have the peripheral coefficient, specific turbine. No, total efficiency. You have the net head. No, so different to the different head. You have the different type of turbine. Propeller type. It comes out in the recent board exam. Propeller, Francis type, Francis or we have the impulse type. No? So we have the types of turbine. It mentions all here. So we have the non-conventional power. No? So we have the solar power plant. So you can read this. You have the wind power plant. You know already what are wind power plant? No? It also utilizes the wind power to rotate the turbine blade. No? But the turbine blade is no longer through the steam or water power, but the wind. No? So we have the propeller. It's not necessarily called as a turbine, but it's a propeller. No? Propeller. We have the aerodynamic efficiency. We have the tidal power. No? Have you seen a tidal power? Hydroelectric power. This, in Japan, there's hydro tidal power. No? They form an artificial wave, no? To produce power. You have the ocean thermal energy conversion. No? It's by applying the form of heat temperature. No? About 5 degrees centigrade. No? So that's where the temperature is about 5 degrees. So you need to learn more about OTIC. No? So OTIC is also what we call an Rankine cycle. We have a turbine. No? So it vaporizes the water. It's also a condenser. So it works like a boiler, no? Steam power plant. So it's a Rankine cycle. So if you will ask what is an OTIC, what is the cycle of OTIC? That is also a Rankine cycle. We have the nuclear energy. Huh? That is now the current trend. If we put up nuclear power plant is what we call a public issue. No? As a public interest. Which store nuclear energy converted into heat to be used in producing steam for steam turbine. It's still the same with boiler. No? Steam processes. But then again, it utilizes the nuclear cells, the control rod. Huh? We have uranium, an artificial cell, like the plutonium. Huh? So that's all about. We have the fuel core, moderator, control rod, deflector. So you just be familiarized with all the terms. I might include in our final the terms. No? So we have the types. We have the latest and the oldest one. No? Pressurized water, and the fast breeder nuclear power reactor, gas cooled nuclear power. So cooling is very important. No, what happens to the 3 Mile Island and Chernobyl is overheating, no, and due to the floods that destroys the power plant, thereby the cells are overheated, no, that equated or resulted to the malfunction and explosion of the power plant of the nuclear. So these are the advantages. The power required to pump the gas is very high. No? Large flow rates and high velocities are required. So that's why, no? It's a very high, we can consider a very high industry, no? Heavy industry. So much so that many multiple times heavy, no? So there's a need for a good, uh, not only good, but the best expertise, no? To run this kind of nuclear power plant. Okay? So these are the advantages and disadvantages. I may ask that the advantage of disadvantage, no? So that's the end of our lecture.